Let's do this example together because I want to clarify this part, that this B7 is not correct. It should be B8 because the previous year plus the increase. Okay, so we have 1, year 2. Okay, for the cost, it starts from A4. You see, A4, so exactly the same as here. It is A4. But the problem is from the other one, and the reason I'm doing it to make sure you are good with it. So to clarify that typo over there. And so the formula is here. You can see it. I'm not going to type the formula here. And here, when we want to calculate the cost for the next year, it would be this. B8 times 1 plus the increase. And I'm gonna freeze it. If you don't know about freezing in Excel sheets, make sure you understand it, because when you are doing financial analysis, you need that knowledge in Excel. Freezing cells in the formula. And that's it. In that way, we calculate all the costs. Here you see the numbers are the same. And now let's check the formula together. For in row 9, the formula is here. B8 times that thing. But here we have B7. That was the point I noticed while I was recording the previous video. The next one, let's go for this one. For the one at row 11, it is B10 times 1 plus something. For the 4, you see it is B9. The values are correct, but the formulas are not. And that's just some typo that always happens. So here we are calculating the NPV. And here we get, in that way we select all the values. So you see, you can just with click, drag, drop, that type of thing, you can handle the thing. So you see NPV B8 to B12. It covers 5 values. And the rate also 10%. My bad. The interest rate is not 10%. The interest rate is 8%. The gradient was, the geometric gradient was 10%. And it is 480.43. Okay, so you see they are the same, and just that typo. Now that we have such a strong tool that can calculate any present value for us, can we use it for doing our analysis, financial analysis, for example, to compare that if we should do an investment or not? Or even we have two cases, case 1 and 2, and we want to know which one we need to do. Yes, we can calculate the present value based on the specified interest rate, and whichever is higher, we are going for that. So you have a very, for example, sophisticated cash flow, this, and many payment, this time, maintenance, all those things, certification and that thing. And you have another one. It is this. Very simply, just like a financial manager. Clear thinking. Calculate the NPV. Whichever is higher, go for that. But remember that interest rate in this analysis is very important. Here we have two machines, machine A, machine B. Machine A cost us $10,000, machine B cost us $13,000, but the revenue we are receiving or saving from them are different. For machine A, it is $3,000. For the other one, it is that way. Now we want to see at the interest rate of 7%, which one is better. Very easily, you calculate the present worth of A and present worth of B. Present worth of A is $2,300 and present worth of B is $2,624. So it is that way. But pay attention, why we could that much fast to the conclusion, because their useful lives are equal. Both of them are 5 years. And you see, I'm not gonna talk about the calculation. We have already had many examples together. And again, it is another example for you. If you are still feeling that you are being fluent with this formula, this calculation, absolutely go and calculate this present value with many things that we learned together, and make sure you come up with the same answers. So we just use present value analysis to decide which option, which choice I should go with. Absolutely, it would be a legitimate question that you ask. Okay, in the previous case that we quickly came up with the answer, the useful lives were equal. In this case, both of them were 5 years. But what if they are different? Somebody may say, okay, so I'm going to do the same thing. I have two machines. One machine has the 5 useful life, and another machine has 10 useful time. And I'm going to calculate the present value again, and whichever is higher, gonna do that. Do you think it is fair? Use your common sense, my friend. Because before I give you the answer, I want you to develop your own sense of common sense regarding these decisions. Develop your own intuition, instinct regarding this decision. Does it fair? You compare a machine present value that has 10 years of living and another one 5. No, it is not fair. You cannot compare two machines with different useful lives. You cannot compare two economic plans with different lives. You should make them equal. How we are going to make them equal? With this concept. Lowest common multiple. If you are not familiar with this, feel free to use ChatGPT. Feel free to use any generative AI to get taught about these things. It's a very basic mathematical knowledge that for sure you have learned about it even before entering the university. And as always, again, if also you have problem with that, feel free to reach out and I can help you to get that opinion. But the idea is this. For example, when you have 5 years for this machine and you have 10 years for this machine, how you are going to make the comparison between the present value fair? You should consider this one 2 times. And we are going to discuss all these things. But let me show you better here. Lowest common multiple. So we have a plan that is 10 years and it has its investment and everything year 0 and all those things 10, and we have another one that is 5 years. So it is not fair to compare them in this situation. What we need to do, we need to consider this machine for 2 consecutive life. So now you are comparing 10 years of this machine with 10 years of this machine. And that's the point of lowest common multiple. If you have one machine for 2 years and another machine for 3 years, what would be the situation? You need to compare them over 6 years. So the first machine, you are going to handle it over 3 lives. The second machine, you are considering it over 2 lives. So you see, now the comparison would be fair. Makes sense. And as you can see in the slide in front of you, if 2 alternatives do not have the same lifetime, then you must find the lowest common multiple. That lifetime is very important. Example, if alternative A has a life of 2 years and alternative B has a life of 4 years. Now it's another example. Calculate the present worth for A twice. So in that way, you are going to have 2, so totally 4 years. A is installed once and again 2 years later. So to make it fair, if alternative A has a life of 2 years and alternative B has a life of 3 years, choose multiple lives totaling 6 years for both alternatives. And the examples can continue. If you have a machine for 1 year, a machine for 5 years, 5 times of this. If you have a machine for 2 years and 5, 10 times. If you have, and like that you continue. Just one thing you need to make sure. The blocks, the sales, the cash flows, the things that you are trying to calculate, the present value over should cover the same amount of year, no matter they're all reinstallment, no matter they are installment over there, because you need to make the cash flow time frame for them equal. For example, here we have 1, 2, 3, 4, 5 for alternative A and B alternative B 1 time. That's the extra step we need to take when you are comparing two plans that are not of the same lifetime.